The subject of this lecture is energy. In this lecture, I will discuss the concept of energy. I will define the two main types of energy associated with moving objects. Those are the kinetic and the potential energy of motion. I will also discuss the conservation of kinetic energy in relation to collisions between objects. I will talk about the relationship between the change in kinetic energy and the force acting on an object. And finally, I will discuss the conservation of energy principle for a moving object. Let's begin with the definition of energy. Energy is defined as the ability to do work. This is a very generalized definition, but as we will see soon, energy is a concept that cannot be defined with one simple, specific quantity in a specific situation. However, we can relate this statement pretty easily with our everyday experience in terms of if you don't have energy from, let's say, food, then it's very hard for you to do physical work, which means lifting objects or moving objects that are not very light. However, if you ate well, you have the energy to do work. And so later we will also see that there is a relationship between the change in kinetic energy of an object and the work done by a force applied to the object. And so, one more time, energy is simply defined as the ability to do work. As I stated, energy is not specifically defined to a particular quantity that can be measured. Energy is more of a concept that is associated and it has different meaning and different expression depending on the physical situation at hand. The reason for that is because energy is a property that all objects possess, and this property can change from one kind into another. Let me give you a few examples to illustrate this statement. For example, heat energy can change into energy of motion, which later we will call kinetic energy. Where that happens, for example, is a car engine. When the fuel is burned in the cylinders of the car, the pistons are being moved by the expansion due to the heat generated by burning the fuel, and as a result, the car will move. And so the energy that was generated by burning the fuel, the heat energy, was converted into energy of motion, the moving car, which we call kinetic energy. Another example is electrical energy. Converted into heat energy. A simple example of that type of conversion is your stove where you're heating up some food, or a microwave where you're heating up some food. And then there's other kinds of conversions of energies between one kind and to another. And so this is a very important property of energy, to the conversion from one kind into another. Then, because of that conversion, it follows that energy never gets created or destroyed. It only converts from one kind into another. And this is an extremely important property of energy. Again, energy never gets created or destroyed. It only gets converted from one kind to another. That means that it is impossible to create energy out of nothing. And it also is impossible to destroy energy into nothing. Energy simply has to change from one kind into another. If the creation of energy out of nothing was possible, then it would have been possible to create engines that operate without any fuel. Once the engine is in motion, then the engine could operate without fuel because it would create enough energy on its own to sustain its own operation. These types of engines are called perpetual motion engines, and they do not exist. We know that because they have never been, people never were able to create an engine such as that. And the reason why these engines actually cannot exist is because the force of friction between the parts of the engine. So one more time, energy never gets created or destroyed. It only gets converted from one kind into another. This statement here has an important application to isolated systems. If you remember from the previous lecture, I talked about a system of objects and that we consider our systems to be isolated from their surroundings, meaning they do not interact with the surroundings. There is no external force that acts on the system. Because the system is isolated, in terms of energy, that also means that the total energy of the system is conserved at all times. It never changes. Again, what can happen is that the energy of the system can convert from one kind into another, but it will never become less or more. Again, the total energy of an isolated system is conserved. We will use this idea or this follow-up from the statement that energy never gets created or destroyed in formulating the principle of conservation of energy.